Hello there, this is Wellington with PX5 and today I'll show you how to create and use fast queues with PX5 RTOS. So in this video, we'll run through the fast queue APIs, then I'll do a 4 minutes demo and then I'll share some resources. So fast queue is a mechanism to provide communication between threads. And the APIs we'll see in this presentation are not part of the standard POSIX pthread APIs. They're actually part of the PX5 RTOS extended APIs. That's the reason why they all have the PX5 prefix. Fast queues are, as the name implies, faster than standard POSIX messages, and that's because they don't support priority messages or variable length messages. These represent less overhead, so they can be roughly 50% faster. Also, interrupts can send messages via the FastQ try-send API, which can be very useful. Let's take a closer look at the APIs. So before we can use a FastQ, we first need to create it. We use the FastQ create API to do that, passing the handle of the FastQ to create, then any optional attributes, then the message size. Message size is defined in bytes, and remember this is a fixed size. And then the maximum number of messages this queue can hold, and then we check the return for errors. Once the FastQ has been created, we can send messages to that using the FastQ send API, passing the handle of the FastQ, a pointer to the start of the message, and the size of the message in bytes, which of course must match the message size we defined for this FastQ. And then we check the return for errors. Then, to get messages from the FastQ, we use the FastQ receive API, passing the handle of the FastQ, a pointer to the destination for the message, and the size of the message to receive in bytes. Well, checking the size here is more of an extra precaution or a sanity check, as this can prevent many problems later. And then we check the return for errors. All right, it's demo time. As usual, main would start by creating the thread handles, memory area, and variables. Then in line 5, we start PX5 RTOS by passing a random number for pointer data verification. We explained that in a different video. Memory area and the size of that memory area. This will convert main into a thread running at the standard priority of 16. Next, we'll create a fast queue by passing, the handle to the queue, any optional attributes, in this case null, the fixed size of the queue message in bytes, and then the number of elements this queue should support, in this case 3. Now the fast queue has been created. To create another thread, all we need to provide is a handle to this new thread and the entry point for the new thread. Here we can see the child thread has been created, also with the standard priority of 16, same as main. It is ready and waiting to run. Meanwhile, main thread will increment its counter, now at 1, and will send a message to the queue by passing the handle to the queue, a pointer to the start of the message, and then the size of the message in bytes. Notice this message will now appear in the queue, taking up the first space, and then main will increment its counter variable again, now at 2, and add another message to the queue. Now we have 2 messages, so main will increment its counter again, add another message. Now the queue is full. Increment the counter again, and now main will try to add another message, the message number 4, to the queue. But since the queue is full, main will be suspended until there is space in the queue. As you can see, main has now been suspended and is waiting for the space in the fast queue. Also notice that the last attempt to add a message to the queue created this orphan message, which is now sitting in the fast queue thread block. It didn't get deleted just because it didn't have space in the queue. And now child thread is running and it will increment its counter. Then we'll try to receive a message from the queue. It takes the first message. Remember, this is FIFO. It's also important to notice that as we remove this first element from the queue, the fourth message that was waiting can now fit here. Of course, at this point, if main had a higher priority, it would preempt child and try to add another message to the queue. But since they have the same priority, this is not going to happen. So child can now proceed with checking the return of the API and the message content, which is all fine. Then child thread will increment its counter again, try to pull another message. Now we see there are only 2 left. Child increment its counter again, pull another message, incrementing the counter, and it will take the last message from the queue. But child will continue incrementing the counter once again and trying to pull another message. But since there's nothing left in the queue, it's now child thread turn to be suspended, trying to take a message from an empty queue. Main can now run again, and then it will add more messages in the fast queue. Notice the child thread will unblock as soon as main adds this first message to the fast queue. As we can see, child thread has been unblocked, but the message number 5, was not added to the fast queue. That's because this queue already had a thread blocked waiting for this data, in this case child thread, and the message 5 is now in the thread control block for the child thread, and the fast queue remains empty. But now main will increment its counter and add another message to the queue. Now we can see the message showing up here, and this process will start all over again. That's the demo we had for today. Now that we covered the basics of working with fast queues, you might want to take a look at some additional APIs like the fast queue destroy, which will destroy fast queues specified in this API call. Also, the try send and the try receive. These are similar to the send and receive, but instead of suspending a thread when the queue is full or trying to receive from an empty queue, instead of suspending, it will return an error instead. There are several other memory pool APIs, so please take a look at the PX5 RTOS user guide for more information. As always, if you want to get started, make sure to check our website at px5rtos.com. You can email us with questions, requests for information, or quotes at info@px5rtos.com. Thank you for your interest.